So I've brought a few slides on air pollution and also how we are combining this information with health specialists on mortality, morbidity related to it. But I would like to say a few words about extreme weather first. I had anticipated that Pinchas would talk about it, but I think this is a very relevant topic for the region here. My view is a little bit bigger than that of the Dead Sea. It's of the Middle East, North Africa region, which has a very similar climate overall. And if you look at the climate change projections in this area, you will find that the annual average temperature change is not very different than from the global mean. So there's nothing conspicuous about it. But if you look more carefully, you will see that the temperature changes in the summer are much higher, are much stronger than in the winter. And of course that is very relevant for a region that is already very hot. And one of the things that was limiting this type of research was data. We do not have a lot of data in the region because there's a lot of meteorological information actually in Israel. This is also available information. Since a few years this is publicly available. And also in Turkey there is information, but in North Africa it's very scarce. But looking into the data that are available, it's quite clear that climate warming in the summer is much stronger than in the winter. And this is a very difficult situation. And what was also very interesting is that if you talk about weather extremes, and I could ask you the question, if you talk about weather extremes, the first thing that comes to mind is storms and floodings. But most people, maybe not people living in this area, but the most lethal meteorological phenomena is actually heat extremes. Most people that die from weather extremes do not die from hurricanes, especially not in the United States, for example. This has to do, of course, also with being prepared. But most people that die from weather extremes die from heat waves. And we were just reminded that our body temperature is 37 degrees. And if the temperatures are much higher, we have to work very hard to get rid of our metabolic heat. And if it then is also humid, this is almost impossible. And actually there is a limit to what humans can stand. And this depends on the temperature and it depends on the humidity. And in this area, there are also areas where it's not only hot, but also humid and near the seas. So I think Israel would qualify there. But the hottest and most humid region is around the Persian Gulf. And it is something that also caught attention in Europe, because if it's getting really extremely hot in this area, we already have a problem with migration. And there is quite a fear for problems related to climate change and migration, calling this climate refugees. It's not a proper wording, but it's something that's under discussion. So, and now we have data that show that the summer is warming more quickly than the winter. We know also from measurements that heat extremes are becoming really less extreme. We've had temperatures well over 50 degrees in the Middle East in the past couple of years, like in Iraq and Iran, and this year it was in Kuwait, around the Gulf, well over 50, and this is extreme. Now, of course, if you can afford air conditioning, you can maybe alleviate the problem, but not everybody can. And there are also other things to consider. So this is something that is of real concern. And also if you look at climate projections, there is a lot of uncertainty with regard to climate projections. But actually not so much about heat extremes, because what happens in the summer is that in many regions, like in Europe, you have soil moisture. So if it gets hotter, you have more evaporation. It's just as how we function. If you get hotter, we evaporate more to cool ourselves. But if there is no soil moisture, if there's no moisture, then there's no mechanism to cool. And this is what happens in this area, because there is no soil moisture in the summer. The heating is amplifying. So this is of great concern. And you can also see in the models, the projections for the future, is that the uncertainties related to precipitation projections for the future are very large. But the uncertainty for heat projections are very low. So the models are very robustly predicting that in the future the summers will become more extremely hot in this region. So I just wanted to mention this, and actually the hot areas to some degree coincide with what you see here, because what you see here is not only hot but also dusty. Pushed the wrong button. It's looking for anyway, for a pointer. Oh, the middle one. Okay, so you see the hot regions are also the ones that have high concentrations of particles. What you see here is a NASA satellite observation. This is PM 2.5. PM stands for particulate matter and 2.5 for 2.5 micrometer. And if the particles are smaller, they can deeply penetrate into your airways. And that makes them dangerous. So bigger particles get stuck somewhere in between and you can cough them out. But the very small ones get very deeply into your lungs and can do all kinds of nasty things. And what you see here is, actually you cannot observe this directly from satellites, but with some tricks you can derive it. And what you can see is that this PM 2.5 is in regions where there's a lot of dust and where there's a lot of pollution. And what you see here, the scale down here, is the yellow is sort of the safe part, so especially at high latitudes. Also in Australia, you see relatively low concentrations. But in most of the world where people live, actually the concentrations are higher than 10 micrograms per cubic meter. And this is the threshold that is being proposed by the World Health Organization as sort of like a guideline for clean air. And actually it's not a safe threshold, because the safe threshold is much lower, but it's probably also a realistic threshold. And what I can tell you is that most people in the world are being exposed on average to about 40 micrograms, and actually increasing. So that's 4 times this recommendation. Of course not everywhere, but what you can also see is that if you overlay this map, which is the annual average of these small particles, with the population map, you can easily find that about 90% of all people, which is now more than 7 billion, is exposed to these levels that exceed the WHO air quality guideline. So this is a global problem. It's not a problem only for regions that are dusty or polluted like China or whatever. Now this is what you can sometimes see smog from space. This is another satellite image, also being provided by NASA. They have a very interesting website where you can download all these nice pictures. Of course, this is not so nice, but I'm showing this to indicate to you that smog is not an urban problem. It's a regional problem. And we can see it very clearly here because the concentrations are so high. But also in many other regions, including the Mediterranean, air pollution is not very localized. It is a large-scale problem. Sometimes urban activities add, so it's sort of the thresholds are being more easily exceeded. But it's really a large-scale problem, and it has to do with the fact that these small particles are being made by chemical processes in the atmosphere. So you're emitting, for example, nitrogen oxides from traffic, or sulfur oxides from coal burning or whatever. But then you have to convert these gases into particles. The particles that are already there, which we call primary particles, are often much larger. And the small particles are the particles that are being made by chemical processes, which also means that it takes some time between emission and being exposed for these particles to be made, which inherently makes it not a local problem. So you will see high nitrogen oxides in cities, but not necessarily high particulate matter in cities. It's sort of downwind, and the same is true for ozone, which is also a secondary pollutant. So this is something to realize. And of course there is also natural dust. Not all of it is natural, but most of it is, and you can see in this region there is a lot of dust. This was an event here down to the left, lower left here in 2015, and the dust was generated actually in the Middle East. Most of the dust actually also in Israel comes from the Sahara, basically Libya or for example these areas. But in this case and in increasing number of cases the dust comes from the Middle East itself. We don't understand exactly why, but that's one thing that we know for sure, that the dust here is increasing. We know that the sources are increasing very strongly, especially in this area, in Syria, Iraq, and also in Saudi Arabia. So you recognize the Arabian Peninsula and the Red Sea here, and the Mediterranean Israel, etc. And this indicates, again, from satellite measurements, the optical depth. So this is the extinction of sunlight by particles being measured from space in the period between 2000 and 2015. And this is a trend. So you can see most of this here is red, and these are very large trends. In this area, in 2015, we had 75% more dust in the air than in 2000. So in 15 years, it almost doubled. This is a huge trend, and we don't really understand where it comes from. It's probably multiple causes. It also has, for sure, an anthropogenic component. Maybe things like land use change. Also, humidity plays a role. If the temperature goes up, and if there is no moisture, the relative humidity goes down, which means that the particles on the soil are sticking together less efficiently, and they're being blown up more efficiently. So this is something under investigation, but it's an important piece of information that the dust is increasing, and for sure there is also an anthropogenic component in here. Now, I've been working for several decades on trying to characterize the composition of air. So atmospheric chemistry is my field, and what we do is we try to understand what controls chemical concentrations of natural and anthropogenic substances in the atmosphere. And I think we've gotten better at it, and at some point we think also using the satellite measurements in combination with models, we have enough information on a global scale to see also what it does to human health. And another discipline has been working on trying to characterize human health problems associated with air pollution. And they've done that in public health sector for many decades. Epidemiologists have been following people, characterizing under what conditions they live, how they feed themselves, etc. And from this information, it has now become very clear that air pollution is an important cause of we call it excess death. Some people call it premature mortality. But anyway, people die from air pollution. And I'm not sure if you've heard of this Lancet report that appeared recently. It was in December. And the estimate was that 9 million people per year die from environmental pollution. And this is a rather robust number. It is less robust in some countries where data again are scarce, but globally I think it is a rather robust number. And of these 9 million people that die each year, half die from outdoor air pollution. And this is what you see here. This is what also being publicized by this Lancet report. And these are our calculations related to PM2.5. So we calculated almost 4.3 million people per year die from particulate air pollution. About 270,000 from ozone. In total, more than about 4.5 million people per year. And the statistical uncertainty is about plus or minus 25%. Actually, this uncertainty can be a bit larger. But even if you assume a large uncertainty here, I think you still arrive at numbers that are fully unacceptable. And you see the diseases here. Ischemic heart disease, they lead to heart attack, is the largest one. So it's not respiratory disease as you might intuitively think. The second one is respiratory disease, is chronic COPD, chronic obstructive pulmonary disease, with more than 1 million per year. And then we have strokes, cerebrovascular disease, almost 1 million. And then we also have acute lower respiratory tract infections, which also affects children, not only infants, but also children up to 5 years of age, about 700,000, and about 240,000 are children. And these diseases, including lung cancer, about 300,000, are very similar as the diseases that you get from smoking. And I think it's probably very much the same mechanism. And many of the mechanisms, including of smoking, the carcinogenic part of smoking is, I think, well understood. But all the other, like oxidative stress and things that can happen in your body because of the particles that you inhale, are not well understood. So to prove the causal effect between air pollution or the causal effect between tobacco smoking and dying is still very difficult. But the statistical evidence is simply overwhelming, and the numbers are very large. Now, this is a plot that we can now make with these models, and here you see annual mortality attributable to air pollution per year is this in individuals per square of 100 times 100 kilometers, and you can identify the cities. And now, remember what I said, that this is not only an urban problem. The fact that you see the highest concentrations or the red areas in cities is not only because the concentrations are high, but in particular also because most people are living in the cities. But you can identify very quickly the big cities and the areas where a lot of the pollution is and where the people are being exposed. So this is a combination of exposure and the number of people. So I want to summarize that mortality attributable to air pollution causes some 4.5, and this is the statistical uncertainty, million victims per year. It is the main environmental health risk globally, and it's one of the top 5 overall. So we're talking about a small list of high blood pressure, diabetes, smoking and being overweight, and air pollution. So that's what you have to categorize air pollution into. The global number of years of life lost by air pollution is about 120 million per year. So people who die from air pollution related causes, they do not just lose a few weeks. No, each individual, if you divide these numbers, would lose 28 years. So there is a large life expectancy decrease because of air pollution. And it's even larger than from smoking because children are involved. And children tend to not smoke. So this is a very large number. And actually, the number of deaths from smoking is still larger. But the number of years of life lost is very similar because the individual number of years of life lost from air pollution is larger. So we have here 6.4 according to the global burden of disease, but the number of years of life lost per individual is 24. So it's lower than from air pollution. And it's involuntary, and this also has to do with the fact that children are being affected. So I would like to ask your attention for air pollution as a cause of illness and of death, and which has not been getting the attention I think it deserves. It's an interdisciplinary area which needs people from medical, public health, atmospheric, etc., sciences, and we need to put our efforts together to get this problem under control. Thank you very much.
Question before we start the panel discussion. One second, please.
Yes, in Israel, it's well known because of what's in northeast town of Haifa.
Mm-hmm.
It is less known in the Dead Sea because there were no measurements. And what I have shown in my presentation was measurements also of the air pollution which is due to the Dead Sea wells and other the main Dead Sea industry.
Well, we came here yesterday, you could see it. I mean, you can still see it. I mean, it's hazy. And it's not only sea salt being into the atmosphere. By the way, it's not sea salt. It may be some dust, but definitely with pollution. And also, you can see actually it's whitish. It means it's not dust because dust is yellowish. And if it's dust, it will take up pollution and then take up water so that it becomes whitish. But I forgot to mention the estimates for Israel that we have are crude. But in Israel alone, about more than 2,000 people per year die from air pollution. Now compare that with the number of people that die from violence and other things that have much more attention.
Okay, because of time shortage, of course, we will try to make the panel discussion a little shorter, but I would please ask you to advance any kind of questions would you like to the panel, either collectively or individually. Floor is open. Yes, please.
Have you found that I don't think it works now. Okay. Have you found that forestation and afforestation have a role in the pollution? So, for example, Israel reportedly has more trees than it did in the past. Are there any statistics that show that maybe it's reducing pollution levels? And there are places in the world where there's more and more deforestation. Is that a possible cause, or is it too complex with too many interactions in order to interpret that?
is a difficult question, but you can find some answers. For example, the area with the largest deforestation or areas are Central Africa and South America. But what you see there is that the forests are being removed and are being replaced by shrubland, basically. So in those cases, you would not have immediately more dust mobilization. Where you have a lot of dust mobilization is where seas are shrinking. So I would be interested in this area because in all deserts, the particles are large and they're difficult to lift up into the atmosphere because the small particles are already gone. But in new deserts, so where areas where, like in Central Africa, Lake Chad, for example, those are areas where a lot of dust is being released. So to some degree, and also in Russia, there are lakes that are drying up because of stupid water management. Those are areas that definitely create a lot more dust. So land use change is a big factor, or can be a big factor, but deforestation does not automatically lead to more particles. And we see in China, China is really aggressively reforesting some of the deserts, but they still have the problem of the dust. So it's a bit of a difficult situation.
Any other question, comments? Yes, please.
Could you relate to diesel engines as a cause for pollution?
Yeah, diesel, of course, have been a big discussion. Especially, diesel cars appear to emit a lot more nitrogen oxides than was expected, than was reported. The nitrogen oxides can only make particles when there is enough ammonia in the atmosphere. I didn't have time to discuss the sources, but actually in most cases the formation of particles from the nitrogen oxides is limited in ammonia. So in areas where there's a lot of agriculture, you will have more particles, and in other areas it doesn't make a very big difference. So I would think that diesels are more important in terms of emitting carbon, so black and organic carbon, and the nitrogen oxides are bad, but they do not automatically lead to more particulates because it depends also on other factors.
I read that the particles are really small, that they penetrate our lungs and enter the blood circulation.
That's another issue, because diesels are nowadays being, filters are being put on them. So what they do, they have sort of like an afterburner. So to prevent the soot particles to get into the atmosphere, they burn them. But actually what now happens is that the soot particles are not actually burned, they're being slashed into smaller particles. Some of them are burned. But and some people believe that the very small particles are even more dangerous. So you don't see them because they're so small, but they are very small and get into your bloodstream and can do all kinds of nasty things. Now this is not proven, or it's not proven that it has health effects. But it is, some people claim that actually these filters do more harm than good.
Anybody else?
I just want to relate to the question that you asked. I think it has been shown actually the PM1, which means a particle smaller than 1 micron, these are the ones that cause most damage, except that most of the stations around the world don't measure PM1. They measure 2.5 and 10. And so consequently, 2.5 is what they report, but unfortunately, if they would have had the PM1, it would have been more indicative of what's happening.